All right, so today we're going to be working through the let's get ice cream question. So let's jump right into it. Looks like we are deciding to open an ice cream store. And in order to keep track of inventory and sales, we're going to be creating an ice cream store and an ice cream class. So first up, we have our ice cream store class. And the idea here is it's going to have 4 instance attributes: flavors, which is a list of the flavors that are in stock; scoop price, which is the price of a scoop of ice cream, individual scoop; cone price is the price of a cone; and revenue is represents how much money the store has made in total. Cool. Seems like the first objective is to fill out the constructor so that our instance variables store looks like an input to the constructor flavors, input scoop price, and input cone price, and also initializing revenue with a starting revenue of 0. Cool. So let's check out the skeleton here. So once again, we're working on the ice cream store class at the moment. Here's our constructor. Looks like we're taking in flavors, scoop price, and cone price, which matches with all of our instance attributes except revenue, which makes sense because revenue is just going to start with 0. So it looks like all we have to do is bind the arguments into the that are taken into the constructor to actually be instance attributes of the ice cream store that we're creating. So just like the problem spec says, we're going to set flavors equal to flavors. So we'll do that here. Oh, I guess I should be doing this down here. So we'll do that here. Then we're going to set scoop price equal to scoop underscore price. And remember, these are just the arguments that are passed into the constructor. And what the idea here is we're going to bind them so that they're actually instance attributes of the instance of ice cream store that we're creating. We'll do the same with cone price. And once again, revenue is just going to be set to the default starting value of 0. Cool. Okay, let's move on to the next one. So now we're moving on to actual individual ice cream orders. So in order to do that, we're going to write the ice cream class. And this has 2 instance variables: scoops, which is a list of flavors, which we kind of saw before, but now this time it's relevant to what flavors are actually in the individual order of ice cream we're making; and scoop price, which is the price of a single scoop of ice cream. Cool. And the constructor is already provided for us. And the goal is to write the method price. And that is going to calculate the overall price of the ice cream. So let's take a look at the work that they've done for us already. So it looks like they have our ice cream class. And the constructor is pretty similar to what we've seen. It's basically taking in the arguments and binding them to be instance variables of the created ice cream. So we see this example. Looks like we're making ice cream with salted caramel and sesame, where the scoop price is $1.50. If we ask for scoops, we get the inputted scoops list. And if we ask for the scoop price, we get the inputted scoop price. Cool. Now let's move on to price. And the idea here is it's going to return the price of the ice cream order. So if we take a look here, if we have an ice cream with 2 flavors, 2 scoops, I guess, of mint chip, and each scoop price is 1.5, right, $1.50, then that means the price of that ice cream is $3, since for every scoop of ice cream, it's going to add scoop price to that total, right? So now let's go ahead and actually implement price, which calculates the price of the ice cream by this formula, which is the number of scoops multiplied by the price of a single scoop. Okay, so let's think about this for a bit. The price of a single scoop is actually pretty easy to get because that's all the scoop price instance variable is, right? That's the individual, or the price of a single scoop of ice cream. Cool. But how do we go about the number of scoops? Well, we have a list of all of our scoops, right? It doesn't really matter what they are exactly. What really matters is, at least not yet, what really matters is how many there are, right? And what we can do is essentially say the length of the scoops list is the amount of scoops in the ice cream order. So what we can do is we could say, okay, return the length of self.scoops times self.scoop price. Right? And remember, we're putting the self here because these are instance variables on the ice cream. Cool. So now the call to price will essentially multiply the number of scoops that we have by the scoop price, getting us the price of it. Cool. Let's move right along to the next one. Now we want to also expand this capability to ice cream in a cone. So the idea here is we're going to be using inheritance. So we're going to be making a new ice cream cone class, which inherits from the ice cream class. Cool. The only difference being this one has a new instance variable cone price, which is the cost of the cone, which makes sense. The ice cream doesn't need to have a cone price, but the ice cream cone should, right? The constructor, once again, has been provided for us, and we need to overwrite the price method to accommodate the cost of the cone. Cool. And note here it says select the implementation that is both correct and avoids redundant code, since this is a multiple choice. Cool, but let's go ahead and take a look at the code they've given us already. So once again, we have an ice cream cone method or class that we're making, and that's going to inherit from the ice cream method, right? This is the parent class. And the idea here is what's happening in this constructor. Well, we're taking in the same things that we took in from the other one, plus this added cone price. And what we can do, we could just write, self.scoops equals scoops and so on. But you'll note that we've done this work already, right? Our ice cream constructor already takes in scoops and scoop price and sets them as instance attributes. And a classic rule is don't repeat yourself. So the idea here is we don't want redundant code. So what we can use is this super method, which will unlock the parent class's methods, right? So the idea here, this super init, is effectively calling the parent class's constructor. So we'll call the parent class's constructor on scoops and scoop price. And now that constructor is going to handle actually setting those two instance attributes for us. But that's not all, right? We also need to consider this cone price. So below this, we're going to also add a line to set the cone price instance variable to whatever was inputted into the constructor. Cool. And let's move on to the next one, which is actually what this problem is about, is just the price function, right? Now the idea is when you create an ice cream cone and you call on price, you don't want to just run this method, right? Because this method doesn't take into account the cost of the cone at all. So we want to overwrite that method with one that does. So how can we do that? Well, let's work through these options one by one. First up, we have super price, which is basically going to call, similar to super init here, it's basically just going to call the price function on the parent class. It's going to call this class. So it looks like we're doing super price, which in this case would just give us 3, right? Since when we call super price, all we're essentially doing is multiplying the number of flavors times the scoop price, right? But we're not accounting for this 0.5 at all when you just call the price. So to make up for that, we're adding cone price. The only problem here is cone price doesn't actually exist within this function, right? It's not like passed in as an argument here, right? That's not the case. So if we actually want to access the cone price, remember it's an instance variable. So because of that, we need to use self. So this would actually return an error because it doesn't know what cone price is. However, this one would not. And this actually looks pretty good, right? We're getting the price from our parent, or from the parent method or parent class's price. But then we're also saying, hey, also make sure that you add on the cone price, right? And the cone price is just a fixed value for every ice cream cone order. So it's not dependent on the number of scoops or anything. So that one looks pretty good for me. I'll circle that for now. And let's keep looking. What's going on here? So we have self.scoop price times length of self-scoops. Self.scoops looks a little familiar, right? Plus the cone price. So a few things here. So first of all, it has a similar problem with the cone price, right? We know that doesn't work. But let's assume that it did. It did have self.cone price. This would completely work. But remember, the goal is to always avoid redundant code. So ideally, we wouldn't rewrite this line since we have a function that does that work for us. So I would still be more comfortable with this answer. And then finally, this price method here is not referring to the parent's price method. So it's actually going to be trying to call itself, definitely not the intended behavior. And I think it might even error because it's not being called on an instance of ice cream cone. So this one is definitely the move. All right, cool. Now finally, let's put it all together. So we're going to implement the make order method of the ice cream store class. So now we're zooming back out to the ice cream store class, which if you remember was the first thing we ever worked on, right? We built out the constructor, which had the list of flavors the store holds, the scoop price for the store, the cone price for the store, and the revenue for the store, which start at 0. Cool. So now we're back in that method. And the idea is we're going to write the make order method, which takes in 2 arguments: flavors, which we've seen before, a list of the scoops the customer wants, and cone, which is a Boolean, right? True, false value that indicates whether the customer wants their ice cream in a cone or not. Cool. So let's work through these kinds of steps. First, we want to check that the flavors requested are made by our store, right? So the input to make order contains some flavors, and we want to make sure that our store can actually has all these flavors in stock, right? And if so, we want to either make an ice cream object or an ice cream cone object, and that's going to be dependent on whether or not the customer wants a cone, which is where that cone Boolean true false value is going to come in. Cool. And if that's the case, we also want to make sure that we're adding the price of the ice cream to revenue. And eventually, we're either going to return the ice cream object, depending on if cone was false, ice cream cone if cone was true, or none if this flavor was out of stock, right? The store didn't hold that. Okay, cool. So I think we have a pretty good understanding, but we can go ahead and take a look at the doc test too, just to cement it down. So it looks like initially we're creating a ice cream store with these flavors, scoop price, cone price, and we're going to make an order of just 2 scoops of salted caramel, which is a flavor we do hold, and false, not a cone. And you'll see here we get an ice cream object, and it was successfully made because all the flavors matched up. And we asked for the revenue. We see that we multiplied the 2 flavors times 1.5, right? Cool. And we didn't even use the cone price because remember the cone Boolean was false. Now this time we're going to make it with matcha and blue moon, flavors that we hold, so no problems there. But this time cone is set to true, and you'll see here now that we get an ice cream cone object. And when we call revenue, you'll note that this is a cumulative value, right? So we made $3.50 from this order because it's 2 scoops, so 2 times 1.5 is 3, plus the 0.5 for the cone. So we made 3.5, and we're adding that to the 3 we already had. So that ends up to 6.5 total. Cool. And then finally, if we try to make an order for a flavor we don't have, like pistachio, then we should return none and print out pistachio is not in stock. Cool. Okay, let's take a look at the skeleton code. So it looks like the first thing we're handling is the flavor checking, since we're looping through all the flavors, right? For flavor and flavors. So what we can do is we kind of have this templated out for us already, but if something is not in something, then we're going to print not in stock and we're going to return something. So the first thing that comes out to me is, okay, this is referring to one of the flavors that the customer wants not being held by the store, right? So what we can do is we could say if flavor, right? And flavor here represents the, current flavor that we're looping through, right? Is not in what? Well, remember, ice cream store has an instance attribute flavors, self.flavors, which is going to, which represents all of the flavors that the store carries. So if this flavor is not in self.flavors, right? Remember, self referring to the current instance of ice cream store, because this is a method in ice cream store, then that means the ice cream store does not carry that flavor. So we're going to print that that flavor is not in stock, and we're going to return none, just like the problem told us to, right? And none if the store does not carry the flavor in the order. Cool. So now if we made it here, then we know that all of the flavors are safe and, we have them all in stock. So if that's the case, it looks like we have this if else thing where order is being set to either a new ice cream cone or something else. So this is looking to me like we're going to be either making an ice cream cone object or a regular ice cream object, right? And what would that depend on? That would depend on the value of cone, right? So remember, if cone is true, because cone is a true false value. So if we say if cone is true, then we want to make a new instance of ice cream cone. So what does ice cream cone take in? Let's check because I forgot. Ice cream cone, where are you? Oh, I think I scrolled past it. There it is. So it looks like it takes a list of the scoops, the scoop price, and the cone price. Okay, well, let's take a look here. So the list of scoops is going to be our flavors, right? those represent the flavors that the customer wants, right? What's our scoop price? Well, remember the scoop price is set by the ice cream store. So that's actually going to be the instance variable attached to the ice cream store, self scoop underscore price, right? And then finally the cone price, which is another instance attribute on the store, right? Self dot cone underscore price. And just to refresh the memory, we'll scroll back up to the constructor, and you'll see here. So we have the flavors it holds in stock, the scoop price, the cone price, and the revenue. That's the instance attributes of an ice cream store. So we're going to be using these two when creating our ice cream cone instance. Okay. Otherwise, order is going to be set equal to what? Well, that just means we're going to make an ice cream instance, right? Not an ice cream cone instance. So what does this take in? It's going to take in the same thing as ice cream cone, but simply without the cone price, right? Just scoops and scoop price. So we can use what we've written above, flavors, self.scoop price. Cool. So now order is either set to a new instance of ice cream cone, or order is set to a new instance of ice cream. So 2 more things we need to do. We need to return whatever instance we just made, right? Which we have already here. But remember that we also need to add the price of the ice cream to revenue. So what's the best way to do this? Well, remember that revenue is an instance variable on ice cream store. So we need to do self.revenue if we want to update it. And what we can do is we can update that by calling order.price, right? That price method is going to get us the price of either the ice cream cone, or the ice cream. Remember, it doesn't matter which, because ice cream has the method price and ice cream cone overrides that method price. So either way, when you call price, you're getting the right value for that. And that would mark the end of the problem. So hopefully this is helpful.